Running a retrieval augmented generation pipeline locally works in testing, but introduces an immediate risk in production. As user traffic grows, infrastructure costs multiply, and the application backend crashes under the weight of heavy model inference. We solve this by deploying the LangChain RagChain as a managed versioned endpoint. We use MLflow to package the code, Unity Catalog to govern it, and Databricks to serve it as an auto-scaling REST API. This establishes a decoupled architecture. We draw a strict API boundary separating the application logic from the model execution layer. In this new structure, the application backend is strictly responsible for handling user session context, orchestrating incoming requests, and managing database persistence. Meanwhile, the model execution layer handles all the heavy lifting. It manages the LLM inference, executes the retrieval augmentation against your vector store, and generates the final response, which crosses back to the client. Isolating the intensive machine learning execution from the lightweight application logic ensures the system remains stable and responsive, even when traffic volume spikes. The first technical requirement is preparing the raw LangChain code for deployment. We wrap the LangChain workflow inside an MLflow logging command. This action captures the chain definition alongside all necessary configuration artifacts. This creates a reproducible package. Your specific retrieval workflow, your prompt logic, and your model invocation layer are now bound together into a single unit. We verify this capture in the Databricks experiment run details UI. The logged model artifact file structure is visible here, confirming the components are packaged. Capturing every dependency into this single artifact eliminates environment configuration errors when we push the model to a live production server. The raw packaged artifact now moves into an enterprise governance structure using Unity Catalog. Centralizing model governance gives you lifecycle visibility. It provides a single source of truth to track exactly which teams and applications have access to the deployed model artifact. We officially register the logged MLflow model within the catalog. This vital procedure permanently assigns it a specific official version number. Strict versioning creates safety in production. If a newly deployed prompt instruction severely degrades retrieval performance, you can immediately roll back the endpoint to the previous, stable version. Registration transforms an isolated code file into an auditable, trackable enterprise asset. The registered model version requires a host. We route it to a Databricks model serving endpoint. In the endpoint configuration menu, we define the specific operational parameters. The primary focus here is the critical compute scale options. This graph illustrates autoscaling. When user traffic spikes, the serving system dynamically provisions additional compute resources to process concurrent requests. Conversely, when traffic stops, it engages scale to zero. Compute resources shut down completely during inactivity to eliminate infrastructure costs. Waking the system up from a scale to zero state introduces a slight, noticeable cold start timeout delay on the initial API request. You must account for this brief pause in your application front end. After confirming the scaling parameters, the deployment initiates. The status spinner will run until it resolves to a green ready indicator. Combining autoscaling and scale to zero ensures your RAG pipeline remains highly available during peak enterprise hours, while strictly controlling resource costs when demand fluctuates. The final test is securely querying this live serving endpoint directly from the application backend. To make the HTTP request, your backend requires two components: the configured Databricks endpoint URL and your personal access token. The access token must be formatted exactly as a bearer token in the request headers. Failing to include this exact prefix will result in a 403 forbidden error. We execute the post request. The server processes the authentication, runs the retrieval chain, and returns a JSON payload containing the final LLM-generated output. Receiving this payload validates the decoupled architecture. The endpoint successfully handles the entire RAG workload, completely independent of the application logic. By completing these steps, the fragile local script becomes a production-grade inference workflow. We used MLflow for reproducible packaging, Unity Catalog to enforce version governance, and Databricks Serving for cost-optimized scaling. You now possess a managed RAG system that scales automatically, entirely separating infrastructure risk and compute cost from your application backend. Check the description below for copy-pastable code snippets from this deployment, along with documentation on fine-tuning Unity Catalog access controls.